Okay, in this video we're doing Calc AB problem set number 120. The problems and a playlist are in the description below. Let's do it. So the velocity of a particle moving along the y-axis is given by v of t equals 5t cubed minus t to the 3/7. Its position at t equals 1 is y equals 14. Write an expression for the particle's position at t equals 0. All right, I'm just going to start with the fundamental theorem. So the integral from 0 to 1 of v of t dt should be y of 1 minus y of 0. So I'm using y because we're on the y-axis. It's not really, I guess it's kind of implied in the problem. I think that all we need to do to answer this is rearrange this so that it is solved for y of 0. So that's what I'm going to do. Y of 0 is going to be y of 1 minus the integral from 0 to 1 of v of t dt. I think that according to the problem, we could actually stop here, but for the sake of practice, I went ahead and did this. So I substituted values, I reversed the power rule, I used the fundamental theorem, and then I combined things. So I got 269 over 20, but I do think you could have just stopped when you got to the place where I indicated. All right, let's look at the next one. On the time interval from 0 to 11, a particle moves along the x-axis. A graph of the particle's velocity is shown above. On the time interval, the particle's displacement is 6 units, while its distance traveled is 26 units. Okay, and we want to know the total distance traveled by the particle while the particle is traveling to the left. All right, so I'm going to name these things A, B, and C, and then just write down what we know based on it, right? So the displacement is just the sum of the signed areas, so that should just be A plus B plus C. And that's going to be 6. So that's one equation. The distance traveled is 26. So that's where any place this is negative, we take the absolute value or the opposite of it in this case. So that would be A minus B plus C is equal to 26. So I need to basically figure out what B is, kind of. I need the absolute value of B, right? Because that's when we're moving to the left. I'm going to do the only thing I can do here, which I think is add these together. Get 2a plus 2c is equal to 32, which means that a plus c is just 16. And because a plus c is 16, we know that 16 plus b is equal to 6, which means b is negative 10, which is not the answer, right? Because the answer we're looking for is we want the distance traveled, not the displacement on the time interval that you're moving left. So we need to take the absolute value of that. So distance while we're moving left is just 10. All right, let's look at the next one. This is calculator, fortunately, because otherwise I'm not really sure what we would do. The base of a solid is the region in quadrant 1 bounded by the x and y axes and y equals 5 minus 2x over x plus 3. I just use a calculator to graph it. We probably could have done that by hand, but whatever, it's a calculator question. So we want to find the volume of the solid given that each cross-section perpendicular to the x-axis. So what I'm going to do is I'm going to draw in a segment that's perpendicular to the x-axis, and I'm going to call it S. Now the length of S in terms of the problem is the top minus the bottom, and the bottom is just 0, so we get 5 minus 2x over x plus 3 minus 0, which is really just 5 minus 2x over x plus 3. All right, you want to do that every time you're doing these volumes with known cross-section problems, like figure out what S is, and then have your formulas memorized, and then you're just integrating the area of the cross-section every time. So for A, rectangle with height 5 times its width in the xy plane. So the width is in the xy plane, so the width is s, and then the height is 5 times s. So it's going to be s times 5 times s, which is just 5s squared. So to answer this question, to find the volume, we want to integrate that on the interval. So 5 times the integral from 0 to 2.5 of s, which is 5 minus 2x over x plus 3 squared. And I'm going to save that for the end. I'm just going to use a calculator at the end to get all the volumes. For B, we're doing semicircle with diameter in the xy plane. This one you basically have to memorize because you do not want to spend time on the exam actually working it out. So the area of a cross-section here is going to be pi over 8 s squared. I have several videos where I describe where that comes about. But this you should 100% memorize. It's the trickiest of all of them. Equilateral triangle is s squared root 3 over 4. That's also good to have memorized. Otherwise, it's like they'll describe it or they'll basically just be square cross sections. But semicircles, equilateral triangles, definitely have those memorized. So our volume in this case is going to be integrate that thing. So pi over 8, 0 to 2.5, s squared. kind of all of them come down to like some multiple of s squared when you set them up the same way every time. All right, so I took a calculator and I just, did it. And I'm just going to fill in some values here. So our volume is approximately 8.317. And then for the other one, it's approximately 0.653. Those volumes are always smaller than I expect them to be. I don't know why. I just always expect them to be giant. But then they're, not. All right, here we go. Find the volume of the solid formed when the region bounded by y equals the square root of 9 minus 9 over 25, the quantity x minus 5 squared, is rotated about the x-axis. So this is definitely an ellipse type thing. It's an ellipse. And if we did all the math, we could figure that out. But what I'm going to do instead is I'm just going to figure out what the y-intercepts of this are, essentially. And so, sorry, the x-intercept. I want the x-intercept. So I'm basically letting y equal 0 and try to solve. I think you can guess them, because if we can make the quantity x minus 5 be equal to 5, or negative 5. Then when we square it, we'll divide by 25. We'll do 25 over 25, which is 1. We'll have 9 minus 9. I'm going to guess. So when x is 0, I get negative 5. If I square that, it's 25. That'll give me 0. So x equals 0 is one of the zeros. The other one is at 10. If x is 10, then I get 10 minus 5 is 5. Squared is 25. 25 over 25, 9 minus 9. So the other one is at x equals 10, which means that the graph looks something, but not exactly like this. So we are rotating this region around the axis. So I'm going to set it up. So it's going to be pi, the integral from 0 to 10, our whole radical thing, and then we're squaring it. So if this wasn't a volume problem, if it was just try to find the area of that region, much trickier, but not the case. Volumes sometimes are easier to find. So when we square it, it just gets rid of the square root. So I don't know. Let's watch me write that. Okay. So this is what we're going to integrate. This is a straightforward integral. So we're going to get pi. You'll have a 9x. And then here you do plus 1 times the reciprocal. The chain rule just gives you a 1, so you don't have to worry about that. So that's 1/3 9 over 25, which is actually just going to be minus 3 over 25, and then x minus 5 cubed. Okay, now we're evaluating from 0 to 10. When we plug in 10, we get 90. And then when you plug in 10, you get 5. You get 5 cubed divided by 5 squared is 5 times 3, so you get 15. I don't know why that took me so long. And then minus, when you plug in 0, you get 9 times 0 is gone, negative 3 over 25 times negative 5 cubed over 25. So this is going to be positive 15 this time. And so that's 90 minus 30 is 60 pi, which is big, which is what I always expect volumes to be. All right, that's the entire problem set. I hope this was helpful, and good luck.